Okay, so how?
You can sit down. Why do you need to stand?
Because then, okay. Okay, so we're gonna start with the questions of the colleagues. So first, Donfa asked me, "Hey Alex, I want to ask if how do they find the gene NCA and the IGSF8?" So what they did for that is that they used this program called Target Scan Mouse that predicted a list of microRNA, mRNA that had a conserved binding site to this microRNA 7 family.
Sorry.
And then this target scan mouse predicted these upregulated genes. So they're here. These are the predicted upregulated that then after they analyze through RNA sequencing in the experimental group, and then they found this. So
I want to ask if these two genes are significantly upregulated.
So the thing is, they made a list and they chose 5 of them that were very upregulated. Then one that had like a special role, it was the arrestin beta one, and then they chose the IGSF8 because it had a high basal expression. Which, to be honest, if I see the graph, I wouldn't say the IGSF8 has a high or a higher basal expression than others, but they chose it for that reason.
But I want to say there are so many genes here in the figure B. Why focus on this?
Because IGSF8 had the highest basal expression. Then another one, they chose this one, the RP1, that was with an important role, and then they chose the first 5 most upregulated, in which inside of them there is the SNCA.
Alex, sorry, do you record also what is on the screen?
Yes.
I mean the
I can cut it after.
No, but you have this kind of this thing is recorded on the screen. All the screen. Okay.
All the screen.
Okay, then I don't need to record it, right? So
I hope so, right? Oof, I don't know. Now I'm that. Okay. 30 minutes. We can do another video if needed.
Then we can switch the game, right? But that EV capture doesn't have this. Yeah, so it's easy.
Okay, then Verna's question, she asked, in figure 2K and I, what time did they measure the mice food intake? Whether they measure it when the mice is already getting fat. When the mice is getting fat, they turn to eat a lot. So they use this type of cages, metabolic cages, and I think this is automated already. So the cage measures or like this somehow in an automated way.
It's this kind of old type of metabolic cages. We use those ones. Louis probably knows these ones. So it sorts out the urine, the feces, and all the other parameters are measured there. And
so they didn't say a number of when they collected these tools, but I think
it's just all the time. So it's constantly. You can, if you see the curve, you can see like incremental increase. Even they measure it during the day, during the night. They can even trace like when they eat, how much, and so on. So they have all the data, and somehow it seems that they use, sometimes they use this system, and sometimes they use also the real metabolic cage where they use the respiration. Because I don't think this is possible to measure simultaneously these parameters and the.
This picture is not from them. This picture I just found it online.
Oh, okay.
Because I didn't know what it was.
Yes,
a metabolic.
Yes. No, this is kind of
old version.
Type of
Yeah.
metabolic cages, which we call metabolic cages, where they collect this kind of. But nowadays they use metabolic cages which collect. It looks differently. Yeah? So it basically collects the which specific metabolism. So how much O2 do they consume? How much CO2 do they produce? And so on. By that they can measure indirectly the calorimetry. So that's what we conventionally use. This system is also is convenient if you need to collect urine, stool, and I used to work with that one. The mice feel really stressed in that one.
Really? Because
Yeah,
it doesn't have like a blanket or anything, right?
They don't
Or
have
sand
exactly.
or...
That's just a grid, a metal grid. The mice are sitting there. Some of them they cannot stand that even for one day. They start to die.
Wow.
Just because they don't have bedding, they don't have like the
That's what I thought when I saw it.
Yeah, but some are fine. So one should be really careful when one puts them in those ones, because some mice cannot. Sorry? Stool and urine, yes. That's for collecting stool and urine. If you're interested in some parameters from stool and urine, and it should be very precise, you need to really separate them. That's perfectly does that.
Okay. Then Liu asked, my question is, did they also check oxytocin neurons? Okay, so the single-minded homologous SM1 transcription factor seems that it's expressed on the neurons that have melanocortin 4 receptor, and also oxytocin, vasopressin, CRH, and TRH. I think that's the answer. So yes, they did measure in those neurons that express oxytocin. Right? That's what I understood from this sentence.
No, not in this paper.
Yeah, this is from this paper.
Yes, but this is just introduction. Oh, you mean whether you okay?
Oxytocin was.
You mean that the subset of the SIM1 neurons also express oxytocin? So by that you assume that they did measure in the oxytocin neurons. Okay, that's correct. Yeah.
And then they did the luciferase assay in the GH3 cells, not HEC cells.
GH3, what are the cells?
Neuron.
Neuron, which kind of pituitary neuron. Really?
These neurons I suspect that it's easy to transplant used by the luciferase.
Okay, and those are immortalized, like primary neurons. Later.
GH3 is three.
Let's see.
Also neuron.
It's interesting.
Mm-hmm.
It's interesting. I mean,
the first question, they checked the potency neuron, HRP neuron, SIM1 neuron, but they didn't check oxytocin.
yes, but some of the SIM1 neurons do express oxytocin, so it's kind of overlapping population. So some of the oxytocin neurons they did, but they didn't aim to check specifically for oxytocin neurons. So one can, it's sometimes very difficult to use the precise delineation, which exactly cell do you want to check, like magnocellular or parvocellular. That's why sometimes they use double, like CRE and FLP, in order to check, okay, CRE will label this one, this subset, FLP with this one, and only if you have overlap, then you can measure the subset. Yeah, so only those oxytocin neurons which are expressing also SIM1, for example. That's a different setting, but they didn't use that. So there are different strategies how you can make the precise. For example, if you use CAM-K will measure, will label all of the neurons of the. I mean, not all, but like the neurons of the cortex, the hypothalamus, the basolateral amygdala, the hippocampus, of course, and within the subset, intersecting with them, then you can just go for a specific cellular population. Sometimes they do this by using also TET-on, TET-off system. That's also a possibility. And CRE, so combination of both will give you the precise one. So kind of yes and no. So they did measure in some of those neurons.
Okay, then. Okay, now with your questions, you say figure 3 and E and G don't reveal significant changes. That one you were right, and this, you say same for figure 5G. But actually, this is figure 5G, which we see like a bit of a difference, right, on body weight. But they claim it was an exacerbation of the obesity.
No, I meant a different one. Probably it's maybe I mistyped it. I thought maybe 4G. Wait a minute. I meant let's see, what is 4G? Sorry, it was probably my title.
Anyway, but if we look at this picture, will you say that? I mean, there is a difference, but is this relevant already?
And that's the question. That's a different question. I have a different question here about this one. Yes, it was about the figure 3G, yes, and the figure 5J.
Oh.
That was my mistake. Sorry, I meant 5J, not 5G. I need to correct that.
I want it. 5J.
Yes, it's borderline. It's on the edge, but it is like
5J?
strictly speaking, it is not significant. Yeah.
This is 5J.
Sorry. 5J. Yes.
J. This one.
This is this one I meant.
Oh. But okay.
Borderline, yes. I mean,
I have a next one. Yeah, is that because you asked me body weight on 5 years was analyzed without pairwise comparison, as was done for previous data, and the change is of questionable relevance. Had they provide more information about IGF, insulin, and so this is the 5J.
Mm-hmm. This comes again, yeah. But
Yeah.
my previous one was also about the 5J. Yeah.
So why do you think this is not relevant?
No, firstly, this is not significant.
Significant.
No, it is not.
It's not.
No, it should be below 0.05. This is above 0.05. Yeah. If we are talking about strict, so we have a cutoff. That's a cutoff. I'm not idealizing P. Yeah, not at all. I'm not saying. I know this is just a probability. I know this can be relevant even if it's not significant, and I know it could be not relevant if it is significant because it's just a probability. It could be just by chance. But strictly speaking, it is, let's say,
on the normal range.
Almost reached the significance. We can say like that, yeah. Or this change barely or had not reached significance, but was borderline, something like that, yeah. That's okay, yeah. But we cannot say it is significant.
And also, I check what does it mean pairwise comparison?
Okay, like after. Let's jump back. Yes, here. My question was, in all of the settings, in all of the figures previously, in figure 1, 2, 3, they always use the curves of the body weight or some other parameters, and they use pairwise comparisons. So they use two-way ANOVA. That's the right way to do this. And then later, for each time point, they do pairwise comparison. So they do t-test for each of the time point, and then they need to correct the p-value using some Bonferronions or some other post-hoc measurement because they have multiple comparisons. That's why they cannot use just normal t-test, because in normal t-test you have just two measurements. Here we don't have two measurements. We have two measurements on that week, two measurements on that week, and they statistically they influence each other. That's why we need to account for these multiple measurements. That's why these pairwise comparisons, they are like t-tests, but we need to increase the threshold, the cutoff of our p-value. and this is called this post hoc correction, the pairwise correction for multiple comparisons. And here, only in this figure, they didn't use pairwise comparisons. Of course, we understand why. Because
in which? In this or the other one?
No. Like, stay here. Like 5G and H, they would not get any significance, of course. Because it is just barely significant overall for to wake ANOVA. And the relevance of this data is, like, for me, it is, I would be not very comfortable if I would not have some additional phenotypic data. And it seems they don't show any other additional phenotypic data. That was my question. Do they have some fat-related parameters, or maybe food intake, or maybe energy expenditure, or they measured some metabolic age? Because if they don't, this is very, very. It could be true, yeah, and it could be that, okay, so this target is just the contributing one, but you see, so it is just barely reached the significance here. So those are standard deviation here. They use not standard error of mean. So it could be that it reaches significance, but
yeah, should they have like a big deviation?
Just on the border.
They wonder if they have a school here.
Sorry?
They wonder if they have a school here.
Yes, they were kind of cherry picking. Yes, let's face it. Yeah, so they were trying to come up with some. They probably also check some others, which probably we don't know, but it could be that they checked some others, and this is the best what they could find. And this is, I should say, this is not very convincing.
And then with all of this other info, like the fasting insulin, the IGF-1.
Yeah, right. And that this is just what they have to support, because most probably they also check some others, and this is the best what they found to support this, that they have increase of insulin in those which were with the overexpression of the IGS, and they have increase of IGF-1 in those where they have increase of glycemically, and also in the IGF-1. Well, this doesn't necessarily tell us about the pathogenesis of obesity in this case. So they might claim that the primary cause here is rather related to the insulin resistance, and this causes this mild obesity. But I think it is difficult to claim for them that this phenotype which they had before, which is related to the decrease of miR-7, is somehow related to the phenotype which they see here. At this link, I don't see here. I don't see at all. They don't make the experiment where they can prove that these two genes they have directly have to do something with that phenotype there. At least I don't see that. It might be, but they didn't investigate that, or they didn't show the data.
But how could they? How could you do
well, of course, the rescue experiment is the one which could address that. But that's difficult. I mean, overall, we need to understand the work they did here is enormous. It is incredible. Just imagine what they claim, what they call here miR-7 flox is actually 3 flox homozygous. So they cross to each other. miR-7 1, A1, miR-7 A2,
and B1.
and miR-7B together in homozygous state. It's incredible. Triple knockout to have it homozygous, and then cross it also on the transgene, because they also need CRE and also different CREs. It's incredible. This is, I don't know how many years work. I think it's more than 5 years work, like way more. Because to do the, just to generate these colonies, like one by one, you need to have an enormous colony and really a lot of work. It's incredible. It's really valuable work. So then I understand, of course, it would be like too much to demand like even to have this rescue experiment. But because they don't have this rescue experiment, they didn't aim up to the top journals.
This is Nature.
Nature
Communications.
Communications. I know. I'm saying about top journals. You know, I think generally like really enormous amount of work, and really they would deserve to get to the very top, I would say. So it's really a great paper. But maybe this was one of the reasons. I'm just saying, like, what is the reasoning of the editors and the reviewers that could be one of the reasons, because their claim about those targets is somewhat not fully convincing.
Not
to
confirmed.
have the relation to this specific phenotype.
Okay, so for the next one, figure 2H, which is supposedly this, both sexes gain weight. However, the change of SIM3 miR-7 flux versus control is not significant. Oh, it's about what we just talked about, these two-way ANOVA and this and that. Yeah. So here you think that this is not significant.
No, this is not. No. I mean that it was not significant in males. That's what I meant.
Oh, in males, yeah.
Yeah. No. Here, like based on the
Yeah.
on the figures here.
Yeah. Oh, here. Yeah, not.
But it was significant. It is the 20th week.
Yes.
Here on the bar graph, and we can see like where is the 20th graph. So they reanalyze the data again. It's also not something which we.
What do you mean? They reanalyze?
I mean, they show exactly the same data again in two different graphs. Look at the 20th week. In
CHO diet or high
No,
fiber?
everywhere.
Ah.
The 20th week is used here for the bar graph, so they show the same data again.
Here,
Like here is in the form of a point. Here in the form of a bar graph, and then reanalyze them. Let's say at their convenience. So in the way that it fits their story. Yeah. I mean here, like we also see, like for me, the main thing to see the curve, because I want to see the dynamics. If I see the dynamics, I don't need to see this. So for me, that's convincing already.
This maybe is a bit more quantitative. The graph, the bars.
Not for me. I mean for me, the quantitative means that I see the whole curve, how it develops. So I don't need to see like the specific. Don't need to point me to what they want to see. I want to see everything. You know, that's why I really don't really need to look at that box, because if I am interested in the week 20, I just look at the graphs and then I can compare. Of course, by that way, what they want to stress is that the comparison of all four groups in one graph. Yeah, so that's their point, which is okay.
Okay.
Which is fine.
So did they investigate what causes the downregulation of hypothalamic microRNA 7A and B in fasted and upregulation in obese mice? So this info is true. I didn't put it on the presentation.
That's important. That is a very important data.
Because the thing is that what they found was something that they just wrote that it was consistent with previous research. So they didn't found anything new. So that's also because I had a lot of info, right? So I had to. So that's why I didn't include it.
Yes, I think it was previously shown before. Yes.
Yeah, and then I read some of the papers, and for example, the one you showed, they actually I did the table. We can
Oh,
look
you
at
did?
it.
Okay.
Yeah,
That's
we
great.
can look at that.
Okay, I would
So-
love to see it.
So they did do these experiments already, for example.
You know, in the first figure, they also show that miR-7 is the highest abundant microRNA in hypothalamus. And I did the profiling of hypothalamus. I know which is the most abundant. It is not miR-7. Not miR-7, one of the miR-7s. But what they say is miR-7 as a whole.
As a cluster.
They say miR-7A plus B plus miR-7. If you do that, then you have like it is like more than the others. Okay, this I can believe, but it's kind of those are three different species which they mean here, and by that all together, if you take all together, then they are the highest amount. Okay, yeah. So it's about how you put the story, So you have the data, you can tell the story different ways. So that's one of the ways how to tell the story. It's smart, I would say. Yeah.
That's also another thing I wanted to bring out with the other paper that we can look after, because I think the other one has very good info, but it's not very well solved.
That's true.
They need a bit of marketing, I think. Okay, so next one, figure 3J.
Wait. Are we fine with this? So we.
So did they investigate what causes the downregulation? Because this downregulation is allegedly linked to a long non-coding RNA called Serrano and a steric RNA called Sidras. And I just look in PubMed, but there is nothing further than that, more than the interaction itself. So I don't.
No, I mean, these interactions were really, really studied in detail. For example, by David Bartel. He was one of the first researchers who jumped into this one, and it was really. I remember his story in one of the conferences. It's really amazing. And they investigated these interrelations in really high detail. My question is not how mechanistically would this microRNA be regulated. My question is
how the fasting state.
That's
regulating microRNA.
Whether this fasting or this extreme obesity model, how do they exactly what causes this decrease or increase? Because from here. It looks like it is really working like a sensor, right? Sensor of the state, and then by that you have like lower miR-7 means you respond less, and by that you get to eat more, and then by that you kind of counterbalance that. If you are obese, then you increase miR-7 trying to protect. And trying to circumvent that. So it looks like a very interesting mechanism. So if you have this part, that would be really interesting. I'm not saying that they need to do
No, they did not. So the thing is that
difficult.
when I look at it on PubMed, I couldn't find like the root cause of this. I only found the mechanistic studies.
No, I'm just saying that there are still open questions. So you say this fasted and obese state of within the hypothalamus. Already someone already investigated. There is a like decrease or increase in the response to that.
If you see, they have quotes. They are as a reference all over.